In 1989, Japan's Shinkansen bullet train had a problem. It was fast, really fast, like pushing 170 miles per hour fast. But every time it exited a tunnel, it was loud. The noise was coming from a variety of sources, but whenever a train sped into a tunnel, it pushed waves of atmospheric pressure through the other end. The air exited tunnels with a sonic boom that could be heard 400 meters away. In dense residential areas, that was a huge problem. So an engineering team was brought in to design a quieter, faster, and more efficient train. And they had one secret weapon. Eiji Nakatsu, the general manager of the technical development department, was a bird watcher.
Different components of the redesigned bullet train were based on different birds. Owls inspired the pantograph. That's the rig that connects the train to the electric wires above. Nakatsu modeled the redesign after their feathers, reducing noise by using the same serrations and curvature that allow them to silently swoop down to catch prey. The Adelie penguin, whose smooth body allows it to swim and slide effortlessly, inspired the pantograph's supporting shaft, redesigned for lower wind resistance. And perhaps most notable of all was the kingfisher.
The kingfisher is a bird that dives into water to catch its prey. The unique shape of its beak allows it to do that while barely making a splash. Nakatsu took that shape to the design table. The team shot bullets shaped like different train nose models down a pipe to measure pressure waves and dropped them into water to measure the splash size. The quietest nose design was the one modeled most closely after the kingfisher's beak. When the redesign debuted in 1997, it was 10% faster, used 15% less electricity, and stayed under the 70 decibel noise limit in residential areas. And it did all that with the wings of an owl, the belly of a penguin, and the nose of a kingfisher. There's a name for design like this. It's called biomimicry.
The people who design our world usually never take a biology class, believe it or not. So they're novices in how the world works.
That's Janine Benyus. Back in 1997, she wrote the book that coined the term biomimicry. It told the story of the innovations in computing, energy, and health that were inspired by structures in the natural world.
Stick like a gecko, compute like a cell, even run a business like a redwood forest.
Benyus has since worked as a consultant for various companies, trying to get them to understand how to take design ideas from nature. That might mean studying prairie dog burrows to build better air ventilation systems, mimicking shark skin to create bacteria-resistant plastic surfaces for hospitals, or arranging wind turbines in the same drag-reducing pattern that schools of fish swim in. Designers get inspiration from a lot of different places, but Benyus thinks many of them could benefit from looking more at the natural world.
So there's a lot of sort of looking at what other people have done, and what they do is they look at all the others and they get ideas. They literally do, a lot of designers have lots of magazines that they look through. They tear those out and they put them on inspiration boards. But they're looking at other human technologies.
Her idea was simple. Designers should get in the habit of bringing a biologist to the table and let them help solve problems by mimicking nature. And there are three main ways they can do that.
You can mimic its form or its shape. You might create a paint for a building that when it dries, it's got the same structure as self-cleaning leaves. Lotus leaves are notoriously great. They let rainwater clean the leaf because they have these bumps, and the rainwater balls up on the bumps and then it pearls away the dirt. So that lotus effect is physical, and you can create a physical structure on the outside of any product. Imagine that on the outside of your car. Rainwater would clean your car. So that's mimicking form. But there's also mimicking process, the processes in the natural world. It might even be, how you mimic how ants communicate in order to efficiently find sources of food or new places to live. And those processes, that self-organization, has been mimicked in software. In things like autonomous cars and how they're going to move in flocks through the city by talking to one another. That's mimicking nature's process. And then you jump up to the level of mimicking whole ecosystems, right? There's a thing called, that's a buzzword right now that's really hot, called the circular economy, which is essentially, industry saying, there should be no such thing as a byproduct in our manufacturing facility that goes to landfill. It should be used by something else, right? And at the end of a product's life, that product should be upcycled into something else. It's being called the circular economy. Ecosystems do that really, really, really well. You've got a log on the forest floor, and those materials move up into the body of the fungus that eats it. Those materials move up into a mouse, and that mouse material moves up into a hawk, right? And if you think about that as what we'd like to do with local materials being upcycled constantly in our cities, for instance, those ecosystem lessons are really big for us.
And that's the end goal for biomimetic design, making products, systems, and cities functionally indistinguishable from the natural world. Life has been around on Earth for 3.8 billion years, and what designers are starting to realize is that is a lot of research and development time.
The people who design our world have a lot to learn from the natural world. All they have to do is take a look.
Thank you so much for watching. This is one of a series of videos that we're doing in collaboration with 99% Invisible. They are a podcast that does stories all about design. We loved working with them. You should definitely check them out at 99pi.org or on any podcast app.